Well, let's play around with this for a second now. We did this with numbers. What if I replaced the number 10 with the letter M, as in Mary? M. You know, the first of those two factors in the parentheses. Well, I have to do that for the other guy, right? But that wouldn't change the value. It'd still be the truth of the equation. It's still true. The log base 10 of m times 100, if it's equal to 3, well then, that's the log of the product, 3. That would be equal to the sum of the individual logs, log base 10 of m plus log base 10 of 100. Now, what if I replace the 100 with a letter also? The second factor. What if I replace that 100 with the letter N? Yeah? And I'd have to do that down here also, otherwise it wouldn't make any sense. All right, let me do that. Now on the letter N, oh, maybe I should have made him red. This guy I should have made red. There we go. Now, so log base 10 of m plus log base 10 of n would be equal to the log of the product, wouldn't it? So the sum of the individual logs is still equal to the log of the product. We're just using letters now. Oh, but wait a minute. Log base 10 of m is equal to 1 I have over here. Oh, if we have letters there, we can't use a letter for the answer. Let's put a letter there, an unknown x. Oh, I like that, and that's good. And what about n? Log base 10 of n. We won't say 2. We'll say y. Right? That's y. Huh. That would be y. And so log base 10 of m is equal to x, and log base 10 of n is equal to y. I hope that doesn't look like a 4. There it is. That looks like a y. So, whoa, but now when we add x and y, we can't get a 3. What do we really get? We get an x plus y, right? We know that's equal to 3 from what we did before. So this 3 up here, which it was equal to, we'll get rid of that, and we'll call this x plus y, because they're the same. Huh. Still, the log of the product, the log, this guy here, of the product, this guy here, is still equal to the sum of the individual logs. Yeah, it's still equal to it. But wait a minute, what about that base 10? I'm using a number there. And they're all the same, so couldn't I replace it with just one letter? Yes. I'll replace it with B for base. That's good. B for base. So all the base 10s I now replace with a letter. B for base. So let me see if I can go over this now clearly. Log base B of m times n, the log of these products, is equal to this x plus y guy right here. and that's equal to the sum of the individual logs. Log base B of m is equal to x. And log base B of n is equal to y. And if we add up x plus y, we get the what? We get the sum of the individual logs. That's what we get. And this x plus y is equal to this x plus y in the upper right-hand corner. What do you know? So let's just go over that one more time. The log of the product, here's the product. There's the product. And here's the log of the product. The log of the log base b of m times n, which is equal to x plus y, equals what? The sum of the individual logs. What did you say? I said the sum. There's the sum of the individual logs. Here's an individual log. And here's the other one. And here you can see I'm summing them up. And here is the answer, the sum, x plus y, which equals this x plus y in the upper right-hand corner. The log of the product equals the sum of the individual logs. Germeister, are you trying to tell me that if you take this guy over here, the product, this product, if you take the individual factors of this product, and you take the log of this first factor, and you take the log of this here second factor, if you take the log of the first factor and the log of the other factor, and you add them boys up, you're going to get an answer that's equal to the log of the products? Is that what you're trying to tell me? Yes. That's exactly what I'm trying to tell you. Well, that's it. I'm out of here. So long now.